His name is Bruno, and together with his two siblings he's helping scientists embark on one of humankind's greatest adventures, the search for life on Mars. Bruno belongs to a family of 3 rover prototypes. The others are named Bridget and Brian, which are testing the latest in planetary navigation technology. In 2 years' time, a 6-wheeled machine with a brain similar to Bruno's will be launched to the Red Planet as part of the ExoMars mission. There it will look for signs of life in soil samples from below the arid Martian surface and take color images of the surrounding landscape. The British-built rover has start billing in the second half of the €1.2 billion joint European and Russian ExoMars mission. As the ExoMars orbiter hurtles towards Mars at 20,500 mph after its launch on March 14, scientists and engineers are gearing up to start work on the rover that will go into space. Assembling the complex array of mechanical parts and electronic circuits is due to begin at the UK headquarters of Airbus Defence and Space in Stevenage later this year. Testing of the rover prototypes takes place in a giant hangar containing 250 tons of sand strewn with artificial boulders, against a backdrop of panoramic photos from Mars. Speaking at the facility as Bruno trundled slowly by, the rover's top speed is 2 centimeters per second. Head of Science Dr. Ralph Cordy talked about the machine's unique ability to steer itself around obstacles. One of the challenges of going to Mars is that it's so far away in terms of the time it takes radio signals to go there and back, around 40 minutes, he said. It's not possible to drive this sort of machine with a joystick. You'll crash it. So this rover is designed to be semi-autonomous. It can produce its own 3D map of the area ahead of it, look where it's being asked to go, and plot its own path. It's aware that some rocks it can't get over and has to drive round, and it can see ditches and sense what slopes are safe to climb. The rover has one navigational weakness, however, it can get confused by shadows. There are caves on Mars and craters that cast long shadows, said Airbus Defence and Space Communications Director Jeremy Close. To explore those areas, it's more efficient to have a human in the loop. Next month, Major Tim Peake will take part in a pioneering experiment that will see him operate Bruno remotely from space. Major Peake will be asked to drive the rover into a cave simulated by plunging half the Mars sandpit into darkness. Steering the machine through a barrier raised across the 95 feet by 42 feet testing area, he will seek out targets marked with an X. Bruno is a stripped-down version of the rover, missing all its scientific hardware. It is designed to weigh the same as the machine on Mars, around 200 kilograms. That is because the pull of Martian gravity is about a third of the Earth's. The finished rover will have a drill that can bore down 6.5 feet below the Martian surface and extract samples to be analyzed in its onboard laboratory. Unlike any Mars rover before it, the ExoMars rover will look for biochemical signatures of life. They might be organic molecules with a particular left or right-handedness to their structure that indicates a biological origin, or specific minerals left behind by long-dead microbes. The planned landing site is a flat equatorial region known as Oxyplanum, where there is geological evidence of surface water long ago. Navigating autonomously, the rover is expected to cover up to 230 feet per day and as much as 2.5 miles in the course of its 6-month mission. A color panorama camera mounted on a mast in the center of the machine will capture unmatched images of the planet. It will have the ability to put you there in a 3D color environment, as if you were on Mars, Dr. Cordy pointed out. Asked how he felt about the mission, he said, "It will help answer one of the really deep-down questions that we have. You stop and look up into the night sky and wonder, is there life out there? We've now got the engineering and science capability to start trying to answer that question. It's not just in the realms of sci-fi, there are good reasons for believing there could have been life on Mars early in its life, just as there was on Earth. The surface of Mars is not a nice place for life. There are cosmic rays that bombard the surface, and energetic particles from the sun, and the surface chemistry is very reactive so that any organic material would be rapidly oxidized. The place to look for life is under the surface, and that's what this mission is doing that no other mission has. Searching for life brings with it a new set of technological challenges. It is the reason why the rover has metal, not rubber, wheels, and why no oily lubricants can be used on its moving parts. ExoMars rover structures engineer Abby Hattie explained, "You can't have anything organic when you're looking for organic material, even sheets around cables, gaskets and lubricants. To withstand the harsh Martian conditions, high doses of radiation and night temperatures that drop to minus 130 Celsius, the electronics cannot be too delicate either. That rules out superfast systems. As a result, the rover's technology, while in some ways highly advanced, is at 1980s level in terms of speed. Everything has to be a bit clunky, said Ms. Huddy. The electronics have to be rat-proof, military-grade, radiation-resistant, and that makes them slower. It limits the rover's top speed because we're governed by how quickly we can process the view of what's in front of us. The British rover and the Trace Gas Orbiter, TGO, now on its way to Mars together, are expected to provide a good indication of whether or not there is, or ever has been, life on the red planet. TGO is designed to sniff up methane in the Martian atmosphere and tell if it is likely to have been generated by microbes or geology. It is accompanied by a small lander, Schiaparelli, which will test out the parachute and retro-rocket landing system on which scientists are pinning their hopes to get the rover safely on the surface.